if I have to write a scalable software today and deploy it, I just like blindly trust that Amazon is going to do the right thing, and I'll use AWS to deploy everything, and then EC2 does the job, right? But how does scalability work from your perspective? Like, you are the people who are ultimately building that whole architecture, and you're also internally catering to Amazon's services and several products, but also externally there's a facing element of, like, say, folks who are still deploying on AWS, right? Like, so how does scalability work for AWS as a whole?
We think of scalability at AWS. Generally, how we think about things is we obviously need to meet our customers' needs today, but we also want to be in a position to meet their needs 3 years from now. And this is true whether you're an external facing product or an internal product that's leveraged by other teams at Amazon. You can take an AWS service like S3, which is a gargantuan service. It's basically like the blob storage, de facto blob storage used basically the world over. A service like that, which is already massive in size, is still doubling in size every year. When we look at that, we use that as a baseline to figure out what is our system capability today, what are the system capabilities that we can get by incrementally improving things that come from generational updates of hardware, generational updates of the software stack. Like most of our microservices are written in Java, right? And so you get pretty decent incremental benefits when you upgrade from JDK to JDK 11 and from JDK 11 to JDK 17. But a lot of the times, these incremental improvements are not enough to meet the needs 3 years from now. And so you need these large software re-architectures for components in your system that are starting to become bottleneck for your customers' needs. And generally, these re-architectures are things that take a couple of years' time. So they need to be planned a couple of years in advance. And so that's generally how we decide during our planning cycle on what to invest in, whether to invest in incremental improvements, how much to invest in features, and how much to invest in re-architecting things to meet our future needs.
Hello, and welcome to another episode of Building It Big. If you've been somebody who's developed software applications and uploaded them, or have used any kind of cloud services, you've most likely used Amazon Web Services. Now, when you deploy on cloud, there's so much of benefit that you get with scalability, ease of deployment, and other functionalities. But have you ever wondered, how does AWS and how does Amazon manage its own deployments and scalability? So to unpack it further, today I have with me Rajul Bhatnagar, who is a software engineer at Amazon. Rajul, again, thanks so much for joining us today. So I'd love to know more about, you mentioned Apollo is the deployment engine and the team, right? So what exactly is Apollo? Can you give us a little bit of an introduction to that as well?
Sure. A lot of you have probably used a lot of the cloud service offerings that Amazon offers. You've probably shopped on retail website, probably seen your favorite show on Prime Video. But what the problem that Apollo solves is providing a way for these service teams to deploy their software onto their fleets. So as you probably heard, right, Amazon is famous for using the microservice architecture. So a particular Amazon offering, let's say Amazon retail website, it's composed of thousands of microservices, and we need a way to deploy updates to each of these microservices. So given a microservice, this particular microservice is deployed across multiple regions because Amazon has the offering across multiple regions, and within a region, right, Amazon has multiple data centers that are in geographically distinct locations. So we need to have the ability to deploy updates across all these data centers to these service fleets in a manner such that you maintain availability across data centers. A lot of these services are web services, so they live behind load balancers. You want to make sure that you are keeping sufficient capacity healthy behind each of the load balancers. So just orchestrating all of this is what Apollo does.
Amazing. So you mentioned a couple of things there, Rajul, and I think one thing which I just wanted to like quickly unpack was microservice, right? Like, so you mentioned like commerce will have a microservice, and Prime Video will have several microservices. So what would be an example of a microservice just from any of these applications?
So um, let's take a simple example inside Amazon.com. Let's talk about the shopping cart in Amazon.com, right? So the shopping cart itself is composed of multiple microservices, but there is probably a single microservice that is responsible for fetching the contents that are in your cart at a particular time. So dividing the responsibilities for an application into these self-sufficient, independent, composable units is what like microservices allow you to do.
Amazing. And in the whole of Apollo team, what exactly is your remit, which is the part that you particularly look into?
Yeah, so I'm the technical lead for the Apollo team, and the team is composed of multiple sub teams, and I work across these teams. So there are folks who are working on our customer facing interfaces, so whether that's the website, our internal website, or the set of APIs that internal builders use to leverage Apollo, or set of CLIs, or the data modeling team, or the control plane team, or the data plane team. Like, work with across these different teams to help deliver what our customers need for us.
Amazing. Okay. So you mentioned a couple of teams there. I think one thing which I was just very curious to understand, what is a typical composition of, say, a team like the deployment engine, such as Apollo, right? And I'm looking more at it from a perspective of we have product managers, backend engineers. Like, what makes up for a team like this?
Yeah. So typical service at Amazon, right? It's composed of customer facing interface. So that's your SDKs. It's your website or the console that you use. So we have a bunch of front end engineers who work on the console, and then you have the control plane, which is basically taking user input and starting off work in the system. And then you have the data plane, which is responsible for the steady state operation of the system. So generally the control plane and data plane teams are composed of backend engineers, and then you have product and project managers that help bring product features and product offerings to life. And then you have software development managers who help manage individual people working within these teams to get the best out of them.
Got it. So that's a good summary of the team composition, and thank you so much for sharing that. So I'll go back to the question that we really began from, right? Like, so if I have to write a scalable software today and deploy it, I just like blindly trust that Amazon is going to do the right thing, and I'll use AWS to deploy everything, and then EC2 does the job, right? But how does scalability work from your perspective? Like, you are the people who are ultimately building that whole architecture, and you're also internally catering to Amazon's services and several products, but also externally there's a facing element of, like, say, folks who are still deploying on AWS, right? Like, so how does scalability work for AWS as a whole?
Yeah, so I think that's a really interesting question, Shreyas. So when we think of scalability at AWS, generally how we think about things is we obviously need to meet our customers' needs today, but we also want to be in a position to meet their needs 3 years from now. And this is true whether you're an external facing product or an internal product that's leveraged by other teams at Amazon, right? And so some of the factors that go into this thinking is your customers, right? They like, for a lot of our products, right, those customers are basically doubling every 6 months. So can talk about my team, right, which is the deployment engine that other Amazon teams use to deploy their services. Now you can take an AWS service like S3, which is a gargantuan service. It's basically like, the blob storage, de facto blob storage used basically the world over. A service like that, which is already massive in size, is still doubling in size every year, right? And so when S3 is doubling in size, we need to make sure that S3 will continue to be able to safely deploy their features to their customers, not just today, but 3 years from now. And so uh, when we look at that, we use that as a baseline to figure out what is our system capability today, what are the system capabilities that we can get by incrementally improving things that come from generational updates of hardware, generational updates of the software stack. Like most of our microservices are written in Java, right? And so you get pretty decent incremental benefits when you upgrade from JDK to JDK 11 and from JDK 11 to JDK 17. But a lot of the times, these incremental improvements are not enough to meet the needs 3 years from now. And so you need these large software re-architectures for components in your system that are starting to become bottleneck for your customers' needs. And generally, these re-architectures are things that take a couple of years' time. So they need to be planned a couple of years in advance. And so that's generally how we decide during our planning cycle on what to invest in, whether to invest in incremental improvements, how much to invest in features, and how much to invest in re-architecting things to meet our future needs.
Perfect. So, can you probably talk to me a little bit about one of the components that you folks re-architected, or that essentially became a bottleneck that you thought, okay, now this needs to be rewritten or rethought of?
Yep. Yeah. So, like, so Apollo is a system that was built about 25 years back, right? During the early days of Amazon, before AWS was a thing. It was built to meet the needs of Amazon retail at that time. And the business has evolved massively over the last 25 years. The DevOps space in the industry has evolved massively in these 25 years. Amazon has a lot more verticals, right? And so, uh, like a lot of Amazon, about 25 years back, right? A lot of Amazon was built on the data model for a lot of Amazon used relational databases because NoSQL hadn't caught on by then. And at that time, relational databases served the needs really well. And so um, this served us well for about 20 years. But uh, over time in the last few years, right, we began to realize some of the limitations that relational database offers, and we knew that we'd have to make significant changes to our architecture to meet our needs. And there came a crossroad where we had the options of, so with relational database, right, you can have a single large database that's serving multiple functional needs, and if these needs are sufficiently independent and the data model is sufficiently independent, one of the avenues to evolve this data model with relatively lesser work is to functionally, shard this data such that different functional units move to independent databases that can scale independently. And we did a bunch of that over time, but that also has limits. And then you also need to evaluate what are some of the operational challenges that you have by running a system having multiple relational databases. And so we decided to embark on a journey of moving our data model from a relational database to using NoSQL, DynamoDB, and S3 wherever applicable.
Got it. So there's definitely a bunch of great things that you mentioned there, right? Like, so in terms of like functional sharding and like different components, of course, needing different sort of relational databases and stuff. So when does this problem become apparent? Like, I know you mentioned that in your plannings you kind of look at what is the 3-year horizon. right?
Mhm.
So is it something which, say, if you're doing this today, you kind of knew about this, that okay, 3 years ago this will happen, and like what is the calculation that goes into it? So if you could like break that down a little bit.
Yeah. So, basically, during our planning cycle, the beginning of the year, we look at a bunch of data. We look at what our customers need, what are their projections, and based on that, we discuss, and then we also look at the feature roadmap that we need to deliver, and based on that, we make conscious decisions on whether to improve things incrementally and incrementally reach keep up with what you need and meet the needs in the 3-year horizon, or and sometimes you realize that you need to make these big investments that will take like 2.5 years, 3 years of time, and you need to start making them now to be able to deliver them in time. And a lot of the time, when you embark on this journey of making these investments, sometimes midway through the journey, you realize that you also need to make immediate incremental improvements to keep the business functioning. So it's a massive balancing act.
Okay, and I think the real question that I'm trying to get to is, at what point did this become the highest order of priority for your team, say in the prioritization exercise?
Yeah. Um, so you start getting signals early on, right? When you're operating a system, you start getting signals that um, there's certain components that are running hard, and when you start getting those signals, you go back to your test bed and uh, make sure that you have a very good understanding of where the limits are in your system.
Yeah.
And once you have that understanding of where your limits are, you know that what's the component that's going to bite you first. And so all of this is like an ongoing effort, and when you know that a particular component is going to bite you first, you make an immediate calculation of how much runway you have, and based on that, you decide when to invest in it, whether to invest in it in this cycle or next cycle. Generally, if you have sufficient insight into your system and its scalability properties, you know years in advance that there are particular components that need careful attention and need investment. So yeah, generally you know of these issues a couple of years before they occur, especially if they are sufficiently big issues. Sometimes you're taken by surprise because your customers usage pattern of your service changes, and then you need to react quickly to it. But a lot of these larger issues, more fundamental issues, you know about them
Yeah.
quite a bit in advance.
I'm not sure if this would have impacted, but I'm guessing during the pandemic, some of the spikes might have come, right? Like because people are at home shopping a lot, watching a lot of TV. So that might have, I don't know, if it all put some pressure.
Yeah, no, during the pandemic, definitely, the business grew at an unprecedented rate.
Yeah.
Luckily, you know, just a year or so before the pandemic, we had finished a pretty big re-architecture of our system, and so we had a lot of runway at that point in time, and so we could, the thing that we'd estimated would take us like 3 years to hit. We hit that in about 18 months, but because we had that 3 years runway, it helped us react quickly enough to keep up with that.
Oh, good. So you mentioned when we were kind of starting to talk about the whole problem, right? Like that there
Mm-hmm.
is functional relationship sharding that you could do with any RDBMS, right? Like so that kind of makes sense to me. Then you mentioned that okay, you also ultimately decided to move to NoSQL, DynamoDB. Talk to me a little bit about like what was that decision like, and why
Mm-hmm.
did that occur, and like also in terms of like what were the various solutions which were say available, or like options which were available to you and your team.
Mm-hmm. Yeah, no, that's an excellent question, Shrey. So I guess to answer this question, let me take a step back and try and at a 1,000 feet view, talk about a couple of fundamental differences between relational databases and NoSQL databases, and I'm not talking about the functional differences, but fundamentally, right? Like a relational database is something where a bunch of logic lives in the database engine, and your applications can be relatively simple. And what I mean by that is your applications can rely on a data model where you have explicit relationships and constraints defined, and you can query across these relationships and constraints, and that ultimately simplifies your business logic, right? Um, and the flip side with most NoSQL databases is they're relatively simple. They're basically like a distributed hash map, right? Where you have a key, and based on that key, the data associated with that key is stored somewhere in the system, and you can make retrievals based on this key. And certain NoSQL databases offer some more bells and whistles on top of this concept, but like the concept is still fundamentally that. And so what happens as a result of that is that a lot of the complexity moves down to your business logic, because you can no longer rely on the database engine for querying across these different relationships and constraints. But what NoSQL databases give you is a sense of deterministic performance because of their simplicity. So your data layer can have very deterministic performance independent of the size of the data and the type of the data. And whereas like with relational databases, right, because of their inherent complexity, as different data dimensions grow, you tend to see performance degradation. And so this is basically this fundamental uh, difference that you need to keep in mind when thinking about relational versus NoSQL databases, whether your business case would be such that it would run into some of the challenges that come with relational databases, and whether you can move that complexity down to your business logic. So when we were looking at this decision point, right, one of the things that we evaluated was, can we functionally shard our um, relational database such that different components, different functional components can live on different databases, and scale independently, because you can upgrade or upsize by vertically scaling different databases independently. And we did that for certain components where we needed immediate benefit. But the long-term challenge that we saw with that approach was this non-determinism that comes in relational databases with scale, as the size of the data increases, right? And this becomes operationally really expensive. Like, during that time, like, we were actually spending a considerable amount of time just hand optimizing queries and making sure that the query planner in the relational database is logged to particular query plans, so that when you when the data pattern changes, suddenly the relational database doesn't start executing a different query plan, and the performance of your operation goes from taking like 5 milliseconds to 500 milliseconds. And so we decided that we needed to make a bigger investment, and that's when we calculated the effort it would be required to make this shift to NoSQL database. We decided on DynamoDB because it had been proven as a very reliable offering internally as well as externally at Amazon, and we have a very good working relationship with that team, and so decided to use that as the primary metadata layer, and use S3 wherever we have to store data blobs. And obviously, we evaluated a few different solutions that are strongly supported inside Amazon, and landed on this.
Got it. And was hardware scaling ever sort of one of the considerations? Do you think that would have helped, not helped at all? How did you come up with that?
No, like, I mean, we pushed hardware scaling to as much as we could, and so yeah, we were running the biggest relational database that was available at that time, and
Yeah.
at
Do
that
you,
time.
do you have do you have like any number off top of your head? Like how big is the biggest one?
So yeah, I mean at that time, that database, and this is like 5 years back, it had half a terabyte of RAM, and don't remember the exact core count, but
Sure.
there was no bare metal hardware that was bigger than that
Got it.
to run that particular relation database. Yeah.
Okay. So this whole migration, right?
Mhm.
End to end, how much time did it take for your team to kind of complete this thing?
Yeah, so the migration, because it's a living service, and most migrations at Amazon that are done are done to services that are living, that are continuously growing. You don't necessarily do a migration like this for the entire system in one go, right? So you see what components can be independently migrated. So case of Apollo, right? We were able to migrate the data plane independently of the backend that does the execution of the deployment plan. Basically, the thing that decides what to deploy, when to deploy, and how to deploy. And then the migration of the control plane and the bits that store metadata were done independently, but like end to end migration like this can like take like typically between 3 to 4 years. It takes a while, but like
That's your entire
you are
life
getting
cycle.
but you're getting like incremental benefits along the way as you move certain components, and like
Yeah.
3 to 5 years is actually uh, a pretty typical life cycle for a particular um, AWS component. So obviously, like the customer-facing interface doesn't change, right? Because you can't
Yeah.
break your customer APIs, but like systems behind the scenes are continuously evolving, and like 3 to 5 years is like the lifetime for most components before you need to kind of think about majorly changing,
Upgrade.
upgrading them.
And to your point, right? I mean, these all happen parallelly, so it's not like there's a serialization in terms of okay, let's just do it all
Correct.
in one time. So
Right. They have some of these happen parallelly, some of these happen serially. It's also a game of lining up your priorities and lining up
right,
your sourcing, and so
right,
yeah,
okay.
and also like
So yeah,
like your priorities, and also where your bottlenecks are appearing, where the operational load would move a lot. Like there are all these considerations.
yeah. So looking back, right? Like I mean, now of course you're past this point, there's victory. Yeah. But looking back, is there something that you guys could have done differently that you think of now?
Yeah, for sure, right? Like all these migrations teach you lessons, and sometimes you relearn lessons that people smarter than you have discovered earlier. But like I said, right? Like you want these migrations to be independent, but a lot of time, just because of the apparent layer of coupling migrations and getting them done together, you tend to couple more than one thing together, which means that they have dependencies on each other, and at that point, like if one thing takes longer than the other, everything slows down. And so I think that was the lesson that we learned a little bit during this migration.
Okay, and this is something which I really like asking everybody. Was there any Eureka moment? Like it has happened with me oftentimes when I build products. Like I did something and it worked, and I go like, oh my god, right? So something like that. Any small thing which you guys did, and your customers or even like internal teams just went like, wow.
I think there were a couple of inflection points that helped move substantially faster. So like I mentioned the previous point, right? Like we kind of ended up in a situation where we coupled a couple of components in the system,
Yeah.
and that caused us to move a lot slower than we anticipated. And so we at that point we were like thinking really hard on how to decouple these investments. I mean, we'd already invested a lot, and we wanted both of the investments to complete, but we needed to decouple it to move faster. And so we evaluated how. So there's a system that does scheduling of deployments, and we were able to leverage this scheduler to decouple how the data for orchestrating a deployment is retrieved from the actual orchestration of the deployment, and those two migrations we were able to have them happen simultaneously and independently.
Interesting. Okay, so those who are like, say, starting out or like are actively even building products and software today, right? Essentially, those who want to build scalable products, any advice you have for those folks? I mean, from your plethora of experience working at AWS, what can they do differently, or what are some of those things that people should definitely keep in mind?
Yeah, so I think the most important thing is actually to know your customers' needs and your business needs, right? A lot of people actually focus on scalability uh, prematurely, and they invest a lot of engineering effort in trying to build a scalable, regionally redundant sort of complex architecture. And a lot of the time, like, the business needs change by the time they are able to deliver on this, right? And so that's like, okay, at that point you need to pivot, and spend a lot of engineering effort on this. So I think an advice that is really helped us is to keep things simple and um, make incremental progress based on what your customers need, rather than trying to do too much upfront in one go.
Yeah. Okay. Rajul, that was all my questions. Thank you so much for being here with us today. It was an amazing conversation.
Thank you, Shreyas. Yeah, no, it was great chatting with you and talking about some of these things that I'm incredibly passionate about.
So that was Rajul Bhatnagar, software engineer at Amazon. We learned a lot in this conversation. Some of the takeaways for me in particular have been how Amazon does long-term thinking in terms of having a roadmap around in the 3-year time frame, so that allows you to know what's coming. And overarchingly, just keeping things simple, just understanding your customers better, the businesses that you work with, their needs better. And these are the simple things which ultimately, when delivered perfectly, make it always big, right? So that's the premise of how do you actually build a software big. So that was my conversation with Rajul Bhatnagar. Thank you again for being here today. Please subscribe, share, like, you know the drill. Take care all. Thank you and bye.